And we're live. Welcome to the actual second part of the 10-pin bowling live stream. So I did start working on it yesterday and then realised that the code was pretty much a throwaway because it wasn't architected in quite the way that we needed. So you haven't missed much, fortunately. From the previous time, obviously we originally did our mock, which we still have. And let me just switch to presentation mode. So we still have our mocks and all that good stuff. But what we've done now is we're correctly representing a frame. So a frame is obviously a single turn. There's a little bit of code I've already thrown in here, but it's still fairly simple. So we'll go through that now. First of all, though, let's get the tool window up and view the project. Right. So I'm not sure how it's going to work with this second one. I might end up getting rid of it. In fact, I'm going to get rid of it because it's no good. So let's just throw that away and go back to it. Right. So yesterday, or sorry, in the first part of this thing, we obviously implemented our pin set. So it required a slight change, which was that it needed to implement the operator and equals. This is really for convenience. So what it enables you to do is, if we go to our test pin set, we have a test where we essentially knocked out 5 pins on a second instance of pin sets. We have our main one we're testing. We have a copy. Not a copy, sorry, a separate instance. We knocked out 5 pins, and then what we do is we use the AND equals operator, so it will AND it with the one with 5 pins down, and after doing so, it's expected that it will report 5 down, and of course 5 up, because there is a total of 10. And I'll show you where this is useful. So we now have our test frame class, so a frame is actually a frame, rather than a playthrough as I previously had it. And we've essentially got one test right now. See, there's a bit of dead code there that I'm going to get rid of soon. And the first thing to do is obviously you should create a report what we bowled on that frame. 7 points. So the way it's working now is that it actually owns the implementation of the pins. So you can see here that you have to construct it with a unique pointer to an interface, and it just moves it in there so that it has ownership inside this object here. We still have our turn state, and of course we update the turn state based on if you take a none, get 1 turn, or 1 turn, get 2 turns. And currently, obviously, it's just saying, okay, you've got 2 turns, your turn has ended. And I've probably gone a little bit too far with this because you can return a strike or a spare, which I should, but they're just declared, they're not really going to violate anything. So that's what we've got, and if we run this, it should work. And it does. So you can see we're currently passing, but of course there's different cases for a frame. So this is the simplest one, or one of the simplest ones, which is that you don't bowl 10, so your turn doesn't end. So obviously the next logical scenario is that a strike will end your turn. So scenario frame ends, player gets a strike on the first bowl. So given frame mock pin set, what's it going to do? It's going to handle, I don't need that handle assignment part, just mock pin set, it's a bit too much. Okay, so mock pin set, and we can just copy this basically. So grab that, grab this, and this. Obviously this is only going to get called once, and in fact defaults to 1, so I can get rid of that. And of course we need to return 10 on this one. Okay, so it's going to return 10, which obviously counts as 10 pins down, which is a strike. So when bowl and of course we're going to say, so the thing with the mock is it doesn't need to perform the AND equals. That's the whole point of a mock, so we're just simulating it. So we can simply say mock pin set first bowl, and of course So require anyway, frame, of course. Let's also do frame. Let's type that on strike. I might rename that to frame.result. Not sure yet, but essentially we're saying we got a strike, and we essentially have our score. So obviously, as the rules say, failing test first, and it did indeed fail. Can't read it though. So let's see. Got failures. Turn ended didn't pass. That's obvious, and didn't call anything either. So let's do that. So in order to make the turn ended stop, we need to do either second turn or you know, I don't even need to check that. I should have a test for that. Right, okay, I won't have a test for it now, but I'll do a 2D. Right, so or and is it pins down? Yeah. So we're going to call that. Now technically we're going to call it twice, so I'll need to update my mock for that. But we'll just run this. It doesn't take too long to run. And what do we get? Yeah, look at this. So now I have to call pins down. Saturated call requirement, of course. As I said, it's going to get called twice. And failed. So we're going to update the test alone first. And probably should be consistent about how I use this. So I'm going to indent it. Right. So return 10 twice. So now I've got that set. You could do allow call, but keep it strict for now. And we're still failing because we didn't get a strike back. So this is now failing. So obviously we can fix that. So we have a result. And then if and you got a strike. And if you didn't, you should return pins down. No, I made a mistake. Oops. Forcing me to optimize. Don't make too cool. Oh, nearly. When did this fail? Oh, I've now broken this. Ah, yeah, of course, because actually no, this shouldn't have broken because this should short circuit. If it's none, it becomes 1, if it's 1, it becomes 2, and then we short circuit here. Well, that's interesting. So it's going to call it. It should only call it once. Oh no, it won't. We call it twice. I think okay. To make this a bit more flexible, we'll allow the call because it has to get the number from somewhere anyway. There we go. Okay. So, and I think I'm gonna do the same here as well. There's no the number of times it calls it really matters to the implementation. So okay. So we're going to do the pin. Have pins down and it passes. Excellent. Right. So we've handled two cases now. We've handled the case where you didn't get a strike. We've handled the case where you did get a strike, and obviously we need to handle the case where you get a spare. So let's throw that one in there. And in fact, we can just pretty much copy this one because it's going to be a case of incrementing by 10. So we roll down another 6 on the second attempt. So this is going to return. Actually, I can't let it return 10, can I? I need a sequence now, so it's where it gets interesting. So score sequence. Require. This is going to require some massaging. Speaking of that, yeah. So return 4. And of course, you need a sequence for that. No, don't send them 4. Sequence. Right. And let's just think about the call of this because you need to actually think it through. I'm going to call bold once. I won't touch it. I'm going to check if the turn ended. We're going to call that once. I'm going to bold again. I'm going to check if the code ended. That's twice, and then that's 3 times. So that's once, twice, 3 times. So we have 4 followed by 10 followed by 10. 4, 10, 10. It would probably be nice at this point if we could actually have the mock keep an internal state. Yeah, there's probably a better way to do this with trompeloid, but we'll stick with this for now. Okay, so we're going to get 4, then 10, then 10. So we bold 4 on the first attempt. Actually, not. Let's make this a bit more idiomatic. So ref. Can do it this way then. It's a bit smarter. So we're going to bold 4 on the first attempt. We don't need the L value. We can just give it a fake one. So we bold 4, and then we bold 10. 7 really, but obviously 4 plus 6 is 10. So throw that in there. Place this with a mock. Empty mock, so I'm expecting to get called. And that should be it. So now we expect the turn has ended. We obviously don't expect it's not ended there. And that should do it. I actually wonder if I need the sequence. And, well, yeah, do it after that. Yeah, I might not need the sequence now, but we'll see. So let's just get it working and then we'll try and optimize later. And we get a strike. And in fact, this is wrong. Frame spare. Oh, it crashed horribly. So we don't know where we crashed. So let's debug it. Unfortunately, C-Line doesn't support MSVC, so we're going to switch to MinGW, which sadly, very sadly, is not supported for debugging. Sorry, MinGW is supported for debugging. Takes a little while to build and takes even longer to compile. So I'll switch it back to Visual Studio once we discover why we've managed to make it crash. As you can see, it's nice being able to use GCC8, but my lord, it's slow. Very, very slow. And eventually we'll get there. It might be because I switched these R values, which would be a bit silly because they're const refs, but it's not impossible. Or do I try to? What do I try to do with this? I don't know anything daft there. Oh, I do. Oh no, I don't even need to look. I don't even need to look. I know exactly what's wrong. We're going to go back to MSVC, and I'm going to correct these calls not to use an empty unique pointer, which I moved from. Right, so that's now happy. Let's build it again. Should obviously be faster. Problem is it has to rebuild, sadly. There we go. Okay. So, oh, did I break them? Oh, we broke the strike frame, the strike test. Oh, is it because I modified the wrong test? Oops. I didn't. Yeah, what did I do? I get 7 points. Get a strike. We get a spare. Okay, there we go. So I didn't modify that one. Let's just quickly hit that again. Okay, let's see what's wrong first. Didn't return a spare. And pins down was supposed to be called once. What's it called? That's not one. So this one didn't get called. Or it should have. Right, okay. So, or no, it won't actually, because we do once, call it once there, and then we'll call it a second time there. It won't be called twice because we short circuit, so it's not necessary. Right. So make sure it still fails. And yeah. Okay, let's start fixing it. Or implementing. So we know your turn has ended if it's 2 turns, which is going to be, so this should be fine. Pins down will not be 10 on the first go, it'll be 4, so that should also not fail. Did it fail? Nope, did not. Wait. Yeah, good. So now we just need it to return a spare here. So at the moment we just check if the result's 10. So what we actually need is to now nest this. So if turn state 2, turn a spare, else turn strike. Could have done turn state 1 and strike, but it doesn't really matter. And there we go, we fixed it. That was all it took. I might be able to simplify this. Let's do a quick refactor and see if we can do it. Return. Probably can't get away with that, can I? Because it's a return, yeah, it's not valid for return, isn't it? I could wrap it in the variant. I could do some silly stud decor val stuff, but nah, we'll just leave it as it is. We know it works. Right, so our handling now will account for a strike, it will account for a spare, it knows when the turn has ended. And I suppose the only other thing to do is do a bit of validation. So attempting to bowl again should throw an exception. So let's do that. Right, so let's just nick our strike code. So let's take this, pop it in there, and so we bowl, but we check the turn's ended, we can just expect an exception after that. I think that should do the trick. One sec, let's see. Yeah, let's throw that in there. Right after I'm done looking at something, sorry folks. Bear with me. And what we're going to do is throws as, and the expression is frame.fold. It doesn't really matter what I pass it, so we're just going to give it a ends. And I think we should probably type this ourselves. It's responsible. So we'll call it frame ended exception. Okay, and that's obviously not going to compile. Why is that? Oh, mock pin set. Right. So it's a frame ended exception. Mutable. There we go. Okay, so now we just need to make it compile and fail. So I could make it a member of frame, but we'll leave it as a free class. So class frame exception. And this using statement brings the constructor of logic error into frame ended exception as a public constructor. So it will just go straight to that one. Obviously, if logic error was default constructible, which it might be, but if it was, then you'd only get a default constructor, and we don't want that. We want to be able to set a message, so we inherit that or expose that. Okay, so now we've got that. We can go back to our code, and it looks like it's going to compile. It should fail. And yeah, we failed. And what does it say? Oh, there's the operator and equals. Why would that? Oh, well, we don't necessarily care about requirements, so make that allow. Make sure the test is right. One failure. No exception was thrown when one was expected. Okay, good. So now we can implement that behavior. So we have bold, and obviously we just need to check the turn state, so it should be a pretty much an instant fail. So we can actually use turn ended for this. So if not turn ended. I'll have to fix the mock site. It's going to be a bit messy, but that's fine. If not turn ended, throw. What do we call it again? Frame ended exception. Okay. And I broke stuff, yeah. So I think what we'll do, let's see. 69. I'll just allow the call. Or you know what we can say? Wait, not Andy. Why has that failed? Pending expectation on destroy mock object. I think it's because we failed. Leave that alone. Pending expectation on destroy mock object. No, that's not it, is it? Here we go. This frame is ended. And this test was. Oh, interesting. Okay, so I did break the test. I have a logic error. So. Yeah, there we go. Simple as that. If turn has ended, not if it's not ended. Let's see what happened here. Pending expectation, this frame is ended. Frame is in play, gets a strike on the first bowl. Bold. And this shouldn't have thrown an exception. Right, done. Something's wrong with returning it, so yeah, return turn state equals 2 or pin state equals 10, but probably it's because we're returning 10, aren't we? So our mock is actually broken. So we get a strike on the first bowl. We don't want to do that. So we can, I think we can get away with this. Let's take a ref though. And don't forget to take that ref there. Remove mock pins. And then afterwards we're going to actually change it. So check if you bold, and then it should obviously then return 10 afterwards. Right, so that's going to make more sense. Well, hopefully that'll compile and do what we expect. We're bold enough and we get a spare, yeah, so I need to fix this one up. It seems that you can order these, so you can change the state just by doing that. So I'm going to do that. Let's get rid of the sequence, and we are not expecting it to allow it. And then after we've bold, 10. Okay, so that looks more like it. So just to make it a bit more idiomatic, so 4 plus 6. We know that's 10, but it makes it more explicit that it's got to be the total. Okay. I failed here. Actually called once. Let's just allow that as well. Is it called twice? No, that should be twice. That should definitely be 2. Oh no, it's my test, look. Return 4, and then we roll the second time, and then it's going to be 10, not before, after. Right, so we've got to be careful. Well, I say you have to be careful. You have to never assume that your tests are necessarily correct. But only mess around with one at a time, then you'll figure it out. Okay, so frozen exception, and we failed somewhere. 143, what's broken? Ah, yeah, it's the same problem. Maybe not. Oh no, because it does the. Of course, it's doing the check there. So we're actually going to return 0. And then after we roll, then it's going to return 10. So at this point, before the first bowl, and then after the second bowl, and that should do it. That doesn't do it because I'm using the wrong object again. Be very careful with move from objects. You can still use them, and it's not valid. It's not at all valid, right? Where am I using this? Nowhere else? Nowhere else. Good. Okay. Now it should be. Should be correct. And it is indeed correct. Excellent. So at this point we have a frame, the sort of standard frames 1 to 9, and we have, the results we need. So now we've got a strike or a spare or a score, but it's not quite good enough yet. And the reason it's not quite good enough is because in a game of bowling, when we're scoring, if we get a strike, we need to know the values of the subsequent 2 plays. This is also why the 10th frame is special. If you get a strike on the 10th frame, then obviously that is valid for, you get 2 more plays in order to get the bonus on that strike. So you need to know the breakdown of the individual sets. So in terms of designing this, we can return a general score. What we need to do is obviously keep track of what you got on the first throw. If the score is a strike, then we don't care because there's only that one bowl. But if it's a spare, that still gets a bonus as well. But obviously the spare consists of a first throw and a second throw. So if you had a strike immediately before, oh actually no, it's not. That's not entirely true. If you had a strike immediately before, then you'll get an additional 10 points because the spare is worth 10 points. If it's the one before it though, so say you've got 2 strikes in a row followed by a spare, then you'll count 1 strike, that counted as 1 throw, so that's 10 points, plus a bonus of 10 points. But then when you count the spare, you need to count the initial. You don't count, so I got 4 plus 6. The total bonus would be 10 plus 4. So that's basically first frame was a strike, second frame was a strike, and then the final frame was 4 and 6, resulting in a spare. So when we get a spare, our spare needs to essentially communicate that to us. Because obviously if it's just a well, no, that's not entirely true. If it's not a spare, that's also no good. So what do I need? I need the total breakdown. Either way, so I think this comes down to this is insufficient. And I'm not sure what do you call it? Is it open? It's called an open frame. Open frame. Let's see. What's an open frame? An open frame is first frame. Player made neither a strike nor a spare. Yeah. Okay, so we're going to call it an open frame instead. So I'm going to update the tests to require that. So get strike spare open, and I don't think there's any others that actually check that. Is there? Strike spare. Nope. Okay, so we encapsulate our type, so I just need to make that compile. This effectively counts as a refactor, so struct open, and just have a UNA, which is our usual scoring, and we'll have score or total, and then we need to return it here. And this obviously needs to change to open. Frame open. And total. And it should still work. And it does still work. So we've got our basics. So what we need now is an open frame to give that breakdown. So let's add a new test. We'll leave that one alone because we shouldn't break anything existing. And let's say, not 6, let's say 4 plus 5, so that's 9. So close to a strike, but not quite there. And we're going to then say, well, actually, where it kind of matters. So let's do the ref again. It's going to bite me if I don't. And okay. So when we bowl 4 on the first attempt, so we can simplify this. So don't forget, it requires an implementation that it will invoke the operator on, but that's internal to the mock, so it's not the job of the frame class to make that work. So the implementation is the implementation's job. So we simply make sure it calls it. We know that it calls it, so it's doing what it's supposed to do. So after the first one, return 4. Actually, it's not entirely true, is it? It's going to be 0 and then 4. So 0, and then after the second one, 4. And then after that, we're obviously going to 4 plus 5, so it was 9. So 4 plus 5, bold on another 5. I probably shouldn't put this here, it looks wrong, so put it after it, and then put this here instead. Right. So what we're going to do is we're going to access the object. So and this is reliable because it will fail if it's not open. So we can then require what we need. So I like score better. So we should have required a total of 7. And then of course we got 4 on the first attempt. you have a last, second? Let's put it second, it's more explicit. So you have a total, result the first, result the second. That's sensible. We'll just make it const, so I don't really want to modify it. And let's just make it compile and fail. So obviously the simplest solution here is we can have and since you are meant to always initialize your variables, just quickly clean that up. Right. That should now initialize and work. Well, compile at least. And something didn't work. Let's see. I wasn't expecting the total to fail. Total currently. There's no frame 4+5. We got another 5. Does it inspect the? Yeah, it doesn't inspect pins down. So what did we do wrong? Pins down will return 9. Check turn ended. And we get the score. And it should have called this, which returns 4+5, which is 9. But instead it returned /t. Oh, no. 9. Test was wrong. 4+5 is 9. And now we have it. First is wrong and second is wrong, so we can implement. So the first thing we need to obviously do is we need to store it. So we can have our to 0. And our second. And now, of course, what we can do is set it. So I may end up breaking tests. Actually, no, I shouldn't. They should all be allow call, I think. But if not, we'll make them allow call. Right. So if you've had no turns, then it's the first turn, and of course, first should equal and that's your first score. And I'm going to make a silly error here. It should be wrong. So this should obviously be pins at minus. This should be minus first, but I'm going to leave it as it is. Partly because I might have to fix and clean up some tests, but oh no, I don't actually. Oh no, it's just not doing anything at all. So that one should have worked, and that one should not have worked. So I think it's the test though, so let's have a look. So what do we call here? Bold. Yeah. So we tell them they bold, and it's actually going to return 0. So we should actually do 4 first. And then we're going to return 9 afterwards. Hopefully that won't make it throw an exception. It shouldn't. I don't think it should care. My code shouldn't care about the initial state of the pins. It should only care about the actual value. So no, it's still not right. So pins down, return 4. Oh, I know what I've done. We don't even set the values. So result first, second. Now let's see what we get. Okay, so I think we passed the first one. Yep. So it's printing it as a character because it's 8-bit unsigned, which is a bit annoying. But if you look on ASCIIchart.com, you'll see that that /t is in fact 9. That's obviously easily fixed. We'll now implement the correct scoring, which is number of pins down minus the first score you got. And it's correct. So obviously we've now got the scoring for an open frame. We need to know the scoring for a spare still. I don't need to know the second score when it's a spare, obviously, because we know there's only 10 pins, and we need to know how many you scored on the first go. So we can have a scenario for that, and we can pretty much copy most of this. This should be pretty much the same. So scenario, and we just get the create points on both 5, lock pins there. We bowl 4, we bowl 5. Yeah, cool. So frame defaults a spare. Pin set, we bowl, let's say 7 on this time, bowl down on a 3, second attempt, spare. So we're going to take 7, and then we're going to take 7 plus 3, obviously that's 10, just for readability we're going to do 7 plus 3, and then obviously the score was 10. And we should get a spare, and of course total should be 7. No, of course total is 10. Well, actually we don't even need a total because it's not open, so we're going to there's not going to be a total. There's just going to be a first. It doesn't make any sense to have a total. You know the total is 10, it's a spare. And the first one you're going to set. Right, so now to make a compile, I'm just going to edit our spare. And we'll just initialize to 0 by default. Need a semicolon there, obviously. And let's run it. It should compile and fail. And in fact, it doesn't pass. We ruined it. Okay, so it thinks the frame has ended. Where did that frame? So let's see how we determine if it's ended. Turn state 2, pins down equals 10. Oh, it's our mock. Okay, so we'll need to sequence this then. So we're going to first of all acquire a call. And the first one will just return 4. And then finally it will return 10. Oh no, have I broken the wrong one? Yeah, I have. This was the correct one. So we're actually going to acquire and acquire, and that's going to be 7. And hopefully that should do it. 7. That's going to call pins down. And then it's going to call pins down again. So there's something wrong with our mocking. So we've got to work that out. Expected pins down to be called once. Actually, not cool. I think these are all symptoms of the actual issue. So, this is the mock pins reference, yeah. I think we need do we need a sequence? We probably need a sequence. Let's try that. Okay, let's see what we get now. So that's 10. And we've done that, that's fixed, and of course we've now got a bad variant access instead. Can I do that on an allow? It's probably because it's not returning what we expect. It's going to need to call it multiple times after that. No. Let's try that. Here we go. So first was called spare. I scored first of 7. Expansions of 7. Just set these ones. Don't need that, do I? Actually, in that case, let's just run this one. We should probably move this down. Yeah, okay, so let's just clean this up a bit. And then let's just see if this works without the times. It should be 1 time anyway. No. So once we do that, do that. How odd. Maybe I misread it. Let's just check. Okay, I'm just going to leave that with at least 1. Apparently, that's some weirdness there. I'm sure it's not weird, it's probably just a logic error, but okay. We've got what we want. Scored on first is 0 and it should be 7. So, obviously, we need to fix that, so we can do it. And this should, in theory, be as simple as just adding the word first. So, obviously, we have this set irrespective, so hopefully that should be all it took. And it was. So, we now have a frame object that can represent your turns. It can represent your scores. Of course, if you've got a strike, we don't need to put anything there. We know it was 10 in one go. There's no variables to deal with. So now we get on to the interesting, slightly more interesting case, which is the 10th and final frame. And this is obviously a special frame because if you get a strike, then you can get another strike, and then you can get another strike. And if you do that, we obviously need to reset the pins, because currently this frame class gets pins at the start and there's no reset. So as we've currently designed for, you pass it a new set of pins to represent what's knocked down. But its own internal state is essentially sort of fixed, I suppose is the word. So these can be queried for the final state of the pins. But we maybe later we'll want to get more detailed. But essentially I would argue that this is where we want actually probably a different class for a sort of final frame. So with that particular thing in mind, you have to forgive me, I'm sort of puffing as I go. We need something to know that the turn hasn't ended based on that statement. It's also going to want to have a separate set of pins potentially. Well, there's a few ways we can do it, right? We can either modify the interface so that it implements a sort of clone method or new instance method. So then, of course, if you just say, "Hey, give me a new one," and the implementation will construct and return a new version of itself. That's viable. An alternative is, well, let's have a look at the game rules real quick. I'm going to go to a wonderful bowling scoring site called bowlinggenius.com, and let's see what we can do. So if we get a load of score strikes, we're on the 10th frame. There's no way to get more than 10, is there? So if I get 9, 1, I get one more. Okay, so I always get. I can either get a minimum of. I can either leave the frame. If I leave the frame open on the final frame, then it's still a standard 2 goes. So let's say I get, I don't know, 6 and 2. Yeah. So if I leave the final frame open, you suddenly get 2 goes. But if you don't, you get one more shot. So we need to account for the fact that you get one more shot, and that means that potentially you need 2 pin sets. So we could of course just say, well, simple option is make it construct from 2 of these, right? So it has 2 initial states. And that's probably quite simple. It may not use the second one, so it's slightly wasteful. So if we never use it, we kind of throw it away, create it and throw it away for sort of, well, no good reason at all. Then again, though, considering this design, this would probably happily run on pretty much any small embedded device anyway. I mean, it is using the standard library and it is using exceptions, but we can technically gut those out. But it doesn't feel quite right to have 2 separate pin sets. We can also implement a reset option. That's also viable. Maybe a reset option is the way to go. Because currently we've got an operator for ANDing, we can have a reset. But then again, does it know its state? The purpose of this operator was that you can't accidentally put pins up. So if you give it a set of pins and some of them are up, they'll just be ignored. So the ones that are down will become additionally down, which would handle cases where, you know, some sensor went haywire and accidentally put another pin back up. Yeah, I think we can do the reset option. It's managing the object, it's encapsulated. We're going to go for a reset option. So we need to go back to our test pin set and have a scenario for that. So to why not 7? Okay. Make sure that they're not actually all down. Then and when. Then and we'll just require the rest as well to make it a complete test. Is up. You know what? Obviously 9 should be as well. So let's make it compile first of all. So we're going to stick it in the interface. We're going to need it later. So do I have these arranged by const and non-const? I don't really. Should change that. I'll do that later. So now we have a reset member function. Stick it in here. Where's that underscores? Come on. Okay, and then we just define it. Let's just do it in order. And there we go. So that's not going to do anything yet, but it will compile once I make the mock as well. So just to get above it, this particular one. And there we go. So now we should be able to build it. And everything passed except this, so require pins up, and it didn't do anything. So let's reset it. So obviously we know our own implementation, and we have our own. Wait, where's the constructor gone? Oh, never mind, it's in line, isn't it? So is there a convenient method that will do this? There's a reset. I think set should do it, shouldn't it? That's probably going to do it. Of course, the beauty of tests, I can just run it and find out. And it works. Okay. So we now have the required feature. So we can now go back to our frame class. And I'm going to, first of all, get rid of all this commented code that's full of absolute garbage. We don't need anymore. And now what we can do is, I think probably it's time to make a new class and have a different name for it. So let's do a little refactor first, right? So we should first of all create a header. For some reason my screen capture doesn't capture the menus, but I'm currently just right clicking on include and then doing new header file. So I'm going to call that frame. And you can see it opened it. I really don't need that created by stuff. Good old IntelliJ classic there. And let's start cutting and pasting. So we've got test frame. Scenarios I want the implementation, please. And we can handle that. Don't need that really. And so then we've got frame.h. I'm going to stick that in there. And we're probably missing something. So let's see. Include accept. I should deal with logic error. Yeah. Memory. Do I need memory? Yeah, I need memory because of this. We need an IPin set interface, so that's going to be, let's have that separately. So we've got our interface taken care of, and we need variant, of course. Variant, yeah, it is variant, so that takes care of that, and everything else looks fine. I might do something with these struct tag types. Might move them into an interface. In fact, I might make the whole thing an interface, but that will come later. And in theory, if I go back to the test and I reduce it to simply including frame.h, which is an include, then it should. I don't need this anymore, do I? Do I need functional? Actually, isn't variant supposedly just declared in functional? I'm not sure the variant header is correct. Let's see, std variant is, no, it's in variant. Okay, I don't know why I have, I think that's from earlier messing around. I probably need cstd int though, don't I? Am I using, yeah, I need cstd int. Okay, so it should compile, hopefully. I'm not missing anything. We aren't, excellent, so that's that done. So it's now refactoring the header. So the last part, of course, is to put it in a translation unit. Let's make a source file, frame.cpp, and of course, first thing to do is include frame.h. Now we can start gutting bits out of it. Did this get added? Oh no, it didn't add it, did it? Or did it not add it to CMake for me? No, it didn't. Okay, so that should fix that. Okay, so now we can bring in the stuff we need. So this obviously needs to stay in the header, it doesn't do anything, it's pretty much just a declaration. This needs to stay in the header. These obviously need to live in the header, this stuff does not. So what I'm going to do is, I'll just copy the lot, paste it in. Obviously these don't need to be here anymore. And we need to deal with our constructor. So we're going to reduce it all down to declarations. So this becomes a declaration. This becomes a declaration. As does this. And as does. I might move those to the top in a second. I don't want to do it now. So that's a declaration. These go here. Space, right, that's a bit better. So those all exist, and then we just clean it up. Okay, and then declaration, and then we're back to this issue we had of, see this, I could put frame in front of all of them, or I could do a trailing return type. Probably inclined to do a trailing return type for this because of the size. Although alternatively, yeah, let's do it. Let's do a using statement. So what we'll do is we'll have using call it score T. And then that gets a bit short. Exactly the same. It's just an alias now. Type alias. And then that means we can use it here. And now it will work. So again, it should compile and work. We haven't changed any code, we just moved it around. And it works, excellent. So we have a test frame, we're going to have a final frame as a type. So I'm going to make a new test. And obviously it needs to go just this one. So we need to include our usual catch, and we're ready to test. So probably the most obvious one is that it allows free turns when we get free strikes. So one thing I'm going to do actually now is, so technically speaking, since it's TDD, I don't need to do this right now, because I can still make it pass my tests, but since I'm mentally aware of it, and I know it's going to cause me pain later if I don't, I'm going to interface this now, because you can't really get anything wrong by interfacing. It doesn't involve changing code, so I'm going to make a header called iframe. And yes, it's called iframe. This is not an internet iframe, don't get the wrong idea. And we're going to take frame.h, and we're going to interface it away. So this is going to include iframe.h. Now let's just copy the class and virtualize it that way. So we'll just take this piece and go here. Right. So what do we need to keep in here? Well, the constructor's out, so that's not a problem. We do need, probably should be able to bold, so we are going to need to include the header, so I'm going to cut that out. So that needs the header. This needs C stood in. This needs variant. And that's pretty much all we should need. So this is now virtual. This is virtual. And this should be virtual as well. Okay, so we've just interfacified the whole thing. And that's essentially all we need. So now, of course, why is it complaining? This is literally pure virtual. One problem, it's in need of that, right. So we now have virtual fields. We have our using statement in here. These are all part of the interface. It's going to break. Actually, probably won't break my code because it's going to inherit from it. So now we go to frame. What is the turn state? Is that internal? I think that's internal, isn't it? I don't even need that there. So we can take this out. That's good. We can pop it in here. Part of the translation unit. Yep, that's the implementation detail. No one needs to know about it. And now we just make inherit from it. So now inherits from my frame. It doesn't know what turn state is. No, because it's a type, and it needs to know what it is. So it's not quite an implementation detail. We do have a constructor. Can I get away with removing this? Probably can. So let's just. Oh, I know. It won't be allocatable otherwise. It's not concrete. Okay, so we'll live with that. That's not too bad. Can live in the header. It's just a demonstration anyway. Okay, so it's got a turn state now. So you could abstract the whole thing away with a pimple idiom, which is pointer to implementation, but I think it's taking it a step too far, I think, for this. What we will do though is we'll put this in the initializer list. So should we leave it? Well, let's just do a sandy sign. That didn't change anything, by the way. That's just for consistency. Right. So we now have all of our objects, and it should compile. These obviously now need to be marked override. Not the constructor. It's not that. And override. And then the all-important thing that I nearly forgot, but didn't in the end. And then we default it. So this is so you don't leak the memory if you destroy from the interface. If the destructor isn't virtual, then the implementation's memory gets leaked. It's obviously not good and not what we want. This is why you should build with sanitizers. It will detect it. Detecting that with a test is not that easy. So a test, you can make a test to cause it, but if the test itself won't detect it. But sanitizers will. So you run your tests with sanitizers. That's the way to do it. Right, we have our. What's wrong with this? Has a different return type because I need to get rid of these from the frame. There we go. So now we have hopefully correct implementation. Let's just try and build it and see what happens. Very good. Okay. So, right. So the point of that was that we have final frame, and we need to allow free turns when we get free strikes. So, given final frame instance, and now of course we need the mock pin set. So when strikes in a row, helps you give it a name, doesn't it? You set up the mock, of course. Is it pins down? I think it was pins down, wasn't it? Let's just quickly check test frame. Yep. Should we say 2 strikes right first of all? So we've got bold, and is there a way to copy a line? You'd think there'd be a way to copy a line, wouldn't you? Let's have a quick look at the old editor window. Maybe there is edit, copy line, macros, join lines, toggle page, convert indents, join lines, it's actually a complete current statement, double case. Surely there would be one. Code, what's this? Line up. Okay, whatever. Apparently not. So we're going to bold heights. So we've got 2 strikes in a row. Although would we reset on the second? I suppose we shouldn't eagerly reset. We should only reset when you call bold. So then of course, we probably need a special type for that, though, don't we? Because our variant can currently return a strike, a spare, or an open, but this is not any of those things. This is effectively a bonus. I think we'll represent the bonus type as its own struct and make it a little bit more complex than usual, because a bonus one we'll call it free plays. So either you only had 2, but if you had free plays, then it can consist of what? Strike and a strike, and a strike, or it can consist of a spare and a strike. So that's still free plays, or it can consist of two strikes and then an open, and then not 10. So essentially a final frame consists of a frame plus a bonus, actually, doesn't it? If you think about it. So we'd return either just a frame or something with the frame and the bonus. I think okay. So in terms of structuring, I think we've got reusability here now. So although if it's going to instantiate an actual frame, then the actual frame wants to own the pins. Although we hold it so it has the same lifetime, so we can have a reference. Yeah, okay, this is okay. Right. So require call I forgot to allow call. Don't forget that. Right. So we're going to require the call. We're going to bold. And then well, actually, no, it can't be a regular frame because that would not represent it right. Because a regular frame will only receive one stripe. So, how do we want to represent this? Let's just deal with this first. Should consist of 3 stripes. Okay, so now let's just make it compile. So this is part of implementation now, so I need to include the header. I really don't like the name iframe. I use I for interface, but it's slightly confusing if you're used to developing internet stuff. But you do know it's about bolding, so I'm gonna leave that to the coder to sort of figure out. And of course, from the constructor first of all. So and there's nothing in it, so we're just going to ignore it right now. And then, of course, okay, and then probably should mark it override. And it's still abstract. What am I missing? Turn ended. It's the only one. Excellent. Okay. Type ID can't. It's not type ID. Oh, it's because of this not existing. So we're going to represent our 3 strikes in here. So strike. Is that really a great idea though? Because we could have a variant that represents a an array of variants instead. Let's go with it for now. So we now have an additional state, 3 strikes, and this should now not complain, and it doesn't. Should probably check that the turn hasn't ended as well. Yeah, we're gonna do that. So not ended, not ended. Not ended. And then it should reset. And then finally it should say we've got 3 strikes. So that looks roughly like enough to compile and fail. Okay, forgot about that. Is that viable? We'll just return the wrong thing for now. Ooh, it crashed. I use this, but I shouldn't have. I'll take the ref, so that won't move from it. It won't actually move from it. Score turns the wrong thing, so that shouldn't crash. It doesn't do anything with this type, so that's also a no-op. This is a ref. This remains valid because we didn't move from it. Although I don't sometimes I don't trust MSVC. This shouldn't crash because it does nothing. It won't physically move from the object. Now, if we took by value here, it absolutely would, but we don't. It's a ref. So the question is, why would we crash? Let's see, 33. I don't think there's any reason why that should allow a call. Turn ended. That's obviously wrong, but it shouldn't crash. Let's go to array. We get this far. And just returns true. It shouldn't crash at this point. It should just destruct. Normally, but then again, it is MSVC. So you know what we'll do, just to hopefully maybe work around it. I don't know if this is going to fix it or not, but. That fixes it, I am amazed. Oh Christ, that does fix it. Oh, how daft can you be? Well done, 10 out of 10, Microsoft. Okay, so anyway, we've currently got our first failure, which is that turn ended is true. So, don't require it to be true at the end though, do we? So, Right, so the simplest thing, of course, here is now it should pass the first few and fail the rest. And of course, what we get? Check false. Expected reset to be called, never was, so we need to figure out, we need to fix that first. So we were supposed to reset it, but it's going to fail if I do it before then, so I need to start implementing already actually. So do we need those? Kind of want those. I kind of want that turns struct now. It's probably, you know, it's actually private to it, so we'll have our own, and we'll actually copy this because it's not the same as the one the other one's using. So in order to make that pass, so we first need to switch case. Actually, let's just stick it right at the top. Right, so no turn state. And then of course we need to set it up, so we can have current turn state, turn state 1 goes to 2, I've forgotten this, but the test would catch it, which is you need to break. Technically you don't need that last one, but if someone comes along and puts another case after it, they're going to have a bad time, so it'd be nice to put the break there. And then we have that. So we've now set the state. So 1, 2, 3. So the question is, at what point do we do it? So if it's the first time we call it, then it's none. Afterwards it's going to be 1. Afterwards it's going to be 2. So after we've done this, we can do the check. So actually we don't need to do the check, we do it here. So if it's your third turn, set it to 3 and reset pins. As type 1. Oh no, oh, wait, no. Point new pin state, right. So reset and done. We should probably we do expect this. No, we don't allow it. We should require it. That should fail now, so let's make that pass. Okay. Let's see what we've got to now. So we're not returning 3 strikes, obviously. So we can obviously just cheat. Not strictly cheating, this is how you're meant to do it. And of course false, so we can just say turn Obviously this isn't massively useful, this is hard-coded, but this is how you do it. Safely expanding the design using tests. So at this point we now account for the special case of free strikes. So let's go for the opposite. Let's say that if you leave the frame open, you only allow 2 turns. So scenario, so I'm going to copy most of this. Actually, how much do I want? Given a file frame, and yeah, when the score, when we knock down 4 pins, of course we need some code for that. So what should we do? This. And when we knock down another 4 pins, so again we're going to allow, and let's say another 2 pins actually, just to vary it. So 4 plus 2 obviously. Then right. So require turn ended obviously. I'll take the score. So we're going to std get. Why is that? Am I not missing variant? It has to be included. Oh, silly me. I could probably implement an operator variant, but like you can literally have a conversion operator for this, but I think I'll leave as score for now. So then we can require okay, don't figure out the type for me then, just be like that. Total first and second, so should be a total of 7, 6, not 7, 4 plus 2. First will be 4. Okay. Don't know why that looks weird. Am I missing something? No, that looks syntactically correct. Let's just compile it and see what it says. Something's obviously wrong. Oh, maybe it's not. No, it's not. It's just being stupid. Okay, excellent. So we knock down 4 pins on number 2, and the first thing that's failed is turn end. It's not false. So we need to start implementing. So you bold, new pin state, we update the pin state. So if return state is free, or Okay, so if it's your second turn, no, wait. Oh no, you've just taken your second turn, you took 2 turns. The number of pins down is less than 10, you don't get another 1. So that should make the turn ended pass. And it did. So now we have to return the open score. We need to fill in all that data as well. So we need members for that, of course. So we can have, whoops. Always initialize. Probably don't need to, but we will. And then for the score, I probably need better testing for 3 strikes. Actually, no, I don't. I need just testing for everything except 3 strikes. So let's see if turn state is turn state 2 and choose an auto. Pins down, less than 10. And that will do it. It should give the correct type, but wrong values. So let's see. Score of first should be 4, and it's not, which we know it's not. So in here, if you take your first go, do I want to update this first? No, I don't, because if I reset and then do it, it's going to be terrible. Yeah, it's a nice way of making this work. Because this reset call, I need to put this afterwards. I can't then save the variable here because we haven't updated yet, which is obviously useless. Actually, we could get away with this because the other one's const, so it can't modify it. So you can reset it and then do it again. It's a little bit silly. We'll stick with that for now, so I can give a better design, but it works. So now, of course, it means we can represent it, so we can do so we now got first and we got second. We will probably need a third later, but we'll do all that in a bit. So let's try that. No, sorry, wrong. Yep, we did what we did last time. So we got a total. First is correct from the look of it. Yeah, this is not, of course, because the value here represents the entire state, so it should, of course, be minus first. Then it's obviously correct. And now we have it correct for an open frame. So what other cases have we got? So we've got the case where it's all strikes. If you get a spare, it should be allowed an go, and it should return a type for action. Well, yeah, because it's going to, so we need to fix this case. So yep, that's a good test case. Scenario. Well, what can you get in on the third one? Does it matter if you get a strike on the third go? Because the value of the third go is always just 10. It doesn't have a special. There's no special bonus associated with it. In fact, I think there's no special bonus associated with the second go either. So getting this third go. Correct result. Yeah, because if I compute a spare on the 10th frame, I think you get a bonus for that. Let's just double check that. Let's see. Bowling, scoring. Yes. You know what? There's an easy way to test it. Let's just do an empty frame. So let's see if we get absolutely nothing. And then we suddenly get a spare on the next go. And then we get 1 point. So we get a bonus go. We only get 11 points. So let's just make sure it's not special. We get nothing, and then we get a spare again. But then we get a strike. That's just 20. So the value of the final of the third go is literally just a bonus round, and that's all you can do with it. So the third go is literally just a score, even if it does show up as a strike in the UI. So that means, given, we can copy some of this stuff. Given this, I'll just copy almost all of it. I will copy all of it. Saves me typing. Let's do it line by line though. Wait a sec. Put it below. Then cut this out. Put it in there. Right, 5 more pin set. We knock down 4 pins. And we knock down another 6 pins. Not that. Then let's take my turn. Let's see, we'll score 7. So I'm going to grab that. So turn has ended, involved, and then spare with bonus, we'll call it. So I'll have a spare with bonus, cut that out, get rid of that. So what do we need to check? So require finished our turn. Do I need the breakdowns of the scores? Yeah, I do. So so if you got, so we know it's a spare, so we only need to know what the first is and the last is. So we just have first and bonus, obviously. So score dot first. And that's going to be first bolt 4. That's 7. Okay, and then we need our spare with bonus, so we'll go to the interface. Okay, so we have first of 0 and bonus of 0. I didn't handle getting nothing. I didn't test getting nothing in the frame, but I'm pretty sure it will work. I'll do that later. Okay, so we've got our type. Why does it insist on deleting names? So annoying. Right. So now we have those variants. That's obviously in there. And that should be a valid test. So we're going to see what happens. We've been at this for about 2 hours, so I'll wrap off soon, but we'll just get this done. So we failed on the turn ending, so we know that's wrong. So let's see what we did wrong. Let's make this work. So turn, if it's the third turn, or it's the second turn, and the number of pins down is less than 10, so maybe it's not the test, because the number of pins down shouldn't be less than 10. So 4 plus 6. 4 plus 6 is 10. That's not, is that one that's not false? No, it's not that one, it's this one. So we allow the call. So we've got 4. 1, 2, and then it shouldn't have ended. Should not have ended, but it did. Oh no, because we violated it here. So actually that's where we need to put it after this. So stick it in the correct place. Now it shouldn't screw it up. Okay, did that prevent it from screwing that part up? Yeah. No much called reset signature void. So involve the third time. Did I not expect reset? Oh, I didn't, did I? Yeah, okay, so I'm missing that in the test, that's fine. Let's just copy that. So we should be resetting it here. That should be the final one. phone. Oh. Results in, not results on. I put it in the wrong place. So I should always check your testing. Right. So, is this the last time we call it? Yeah. There we go. I put it in the wrong place. There we go. What have we got now? Yep, excellent. Okay, so now we're just down to the access, so it doesn't return the correct one. So, when we score it, if it's 2 turns and the business 10, then it's that. But of course, we are not going to be in that case. So, bonus. And of course, that takes the first and the bonus, which I need to implement. Well, let's just set it to 0 first of all. I need to fix that. It's annoying that it puts the semicolon in the wrong place. But that should be the correct type. First, we're a bonus, first and bonus, yeah. So we go here. Add the first and the second, so we've only got 3 tries. We don't have a bonus field yet, but we're going to just make sure it returns the correct type. So we're going to run it. Hopefully the first will succeed and the bonus won't. And yep, there we go. That's doing the bonus. So we can now have a field for the bonus. And then we'll just set the bonus here. Of course, the bonus is independent, so we don't need to subtract anything. We'll know if we don't, because we'll fail. We then get the bonus. And it doesn't. And I have a logic error, so this is where TDD is so great. So you can see, obviously, this is going to match. This is going to match. So actually we want and. So the first is less than 10. Then it should be correct logic. And it is. So we could implement some safety checking now. We could make it throw an exception if the turn hasn't ended. Depends what you're looking for. Obviously for the most performant solution, then you just want something that's just going to do it and assume that you always give it the correct input. Alternatively, you can obviously say, well, you know, add some sanity checking. I'm probably more inclined to add sanity checking, since this is whilst it is an effort in TDD, it's also an effort in creating something that you can play with relatively safely and know where you've messed it up if you do. So I'm probably going to throw some tests in for that. So where could this go wrong right now? How can we break this code? Well, I could score bold 4 times. I could call it when my turn should have ended. So let's do that. So if we, when would we not be allowed to bowl? Well, if we, once we played twice, attempting to bowl again, should throw an exception. So let's throw that one in there first. So we'll just copy this. And did I make that part of the interface? I did not. Put it in the frame. Yeah, I did. Seriously, this should be in the interface. So I'm going to stick it in the interface. I'm tempted to put it literally in the interface, but I think we'll leave it out for now because I can't be bothered to refactor all that code. And I need to include still accept as well. Okay, so I think, yeah, we'll put that there, now we can use it. So, let's final frame. Frame exception, so frame ended. Okay, so this obviously should fail now. We have an open frame and we try and bowl again. And let's see. Something else failed. What was it? No match record reset signature void. Okay, that is strictly speaking an error. It called reset when it shouldn't have. We could probably make that more explicit as well. So you can say so now it will actually explicitly fail. It should not accept things. Match of forbidden. Cool. Excellent. So now, when we're here, we can kill two birds with one stone. If turn ended, now it shouldn't do it. Oh, no, not quite. Okay, so, no, because it's calling turn ended itself, and we've already allowed that. Oh dear. Okay, we need to fix the test for the sequence then. So that should be fine. I'm not sure I need the sequence because I only got one require there. Let's Actually, no, I do. And hopefully that won't violate it anymore. Oh dear, what's this? I wish the turn ended. No, if it's the third turn or it's the second turn. Oh, it just makes the assumption that, yeah. Actually, no. So it won't be the second turn. Okay, so let's go to this. Put this back away, that's a second. Okay, let's just validate what that's doing. This one has a third go. So we can call bold. So 1, 2, third one. So that's going to return 7, which is going to break it, of course, because it's. Yeah, of course. So it needs to return 10 and then. Oh dear, okay. Let's just try this first. So hopefully it should go for the first one, then the second. Guess we'll allow the third go. Alright, let's try something again. And that was the problem. Okay. I'm not requiring, I've just said allow. Let's just try that, because I don't really want to, because I'm not testing its behaviour. No, it's no good. Alright, well, we'll live with it for now. Problem with mocking like this is this is not, I don't really want to be testing this. Might be an argument in favour of not using a mock, just using a fake instead. Okay, well it's solid. It's still solid. So now we're not allowed to bowl a third time, so that fails. Attempting to get the score before the turn has ended. Well, I mean, you could. It's a bit stupid. I could make it throw an exception. But I suspect that's probably not necessary. See, perhaps another way that this could be implemented, and you can actually still do this sort of after a bit of refactoring, is that when you call bold, rather than returning nothing, it would actually return a new type via an interface. So it would manage its own state transitions. So you would essentially not even have to check now, because you just get the result object, and you could basically use the type system for a state machine. But for now, this kind of does what we need. I believe it gives us all the data that we want as well. So we essentially have a test for whether the turn has ended. We can never have ended our state on the first turn, of course, it's impossible. So we know that's true. What do we need now? I suppose we need a frame set, really. I can't think of any bugs in this. Let me just check frame. Did that throw exceptions when you? Yeah, it did. So this one had the same check. This can't. Oh wait, I had it to do here. Fail if turn state none. Why would that fail? I think I might want to remove that. If it's no, if it's 2 or oh yeah, that's true. So we should have a test for that. So let's add a test here. What's wrong with that? Use that when and that should be a pretty terse and reasonable test. Okay, so it's failing on a mock, but it shouldn't even be calling a mock, so that's fine. That's a failing test, that's good enough. So how's the logic in this? If it's turn, if it's 2, it's not 2, it's 1. Technically the pins down shouldn't matter, so I think we're gonna just have cases, because you might want to load a frame with some pins already down. Like if you needed to reset a frame, you might want to simulate it, so we're going to just force it. And we fixed it. So we should probably have the same test in the final frame as well. So we can do that easily enough. We're just going to clone it, reuse it. just so it's not completely the same. And let's see what we get. I think this would also cause a problem. Oh, it doesn't. Okay, well, we need to inspect that. So let's see. No, the turn state's not 3. Turn state's not 2. And the pins down is. So let's see, if it's 3, that doesn't matter, so go to this. It doesn't initialize to none, right? Yeah. So it's not 2. So we're already safe here, so this is a confidence test. So after analysing it, we know that this won't match, so we'll go to the next part. Then inside the brackets, the return state's not 2, so we don't bother checking this, so we just return false. So we are in fact okay. But what about after one turn? So what we're going to do is, what can we nick here? We knock down 4 pins. I need this much. We've got an alcohol and pins down. We already tested this actually. This is probably going to be. This is just a confidence test really. But we'll vary it slightly. So let's say we'll knock down no pins just to vary it. Running under time. Okay. So not with 0 pins. It does the thing. Shouldn't have. This might work. Yeah. So this is just confidence testing now. These two. We should make sure though. So let's see. I'm going to call this. It's going to go to this state. It's going to call this once. That's fine. It's going to go here. It's going to not match this. It's not going to match this. It's already false. So return is not ended in that case either. If we're in the second state and the number of pins down is less than 10, it must have ended. Otherwise, it hasn't ended. And the number of pins down, whether you've got a strike or whether you've got a spare, doesn't matter. But let's think about getting 3 strikes, because that's something we have before. So actually, if you have 1 and you take your go, it's 10 down. If you get a strike on the first go, we need to reset you. So in fact, we should have a test for that, a modifier test. So when we get 3 strikes,
bowl, and then we're going to require a call to reset as well. So you should, in fact, call reset there as well. So that should fail. So we got most things correct, but there's some stuff you need to think about. So it's supposed to call reset, we never did. So we took no goes. It's now our first go. So all we need to do is if, you know what, let's just do the naive approach that will fix one test and break another. Make sure we break tests. Yeah, so over final frame. Yeah, we broke all of these. So now I need to not break them. So if will this pass? It probably shouldn't pass actually. Yeah, so that should have failed. I need to expect not just a call to that, but to the and equals operator. So let's go and fix that. So at least 2 times. At least, is it going to be 3 times? How many times we call it? Once for this one, once for this one, once for this one, and then again. 1, and then 2, 3, 4. So at least 4 times actually. Actually now it needs to be 5 though, so it's going to be 1. This kind of breaks refactoring a bit, but I think at this point, given that this could screw up the scoring quite badly, I'm going to go with it in this particular case because it is actually crucial to the logic of the implementation. It's not really very nice, is it? Yeah, not using the mock to validate it in this way is not best really, but it will do it. So we're going to require 5. In fact, we're going to just require exactly 5 times. Yeah. So what we need to do probably a better way of doing this really is the pins should be a fake, not a mock, and then it will hold the internal state rather than just trying to fake it in the test. But this validates it. The problem is I can make this test pass by simply putting this before reset. Actually, that's a good point. We can make that not happen as well. So let's say 4 times. We can couple it to this. So we're going to couple these 2 together. So this makes it a little bit less silly. So we do. Of course, we need to call reset first, not second. So reset and then read it again. So that
does, which is not necessarily great, because you don't know if it's actually you or not, so make it fail first. Yeah, that's not supposed to happen. Let's do it properly. So this is, how many times is it going to be then? So we call bold once here, so it should be once, and then afterwards we can allow it to go on. In fact, no, we're going to sequence it. So require this column here, and then we're going to do it again here. I'll make this one correct though. Right. Bold, and that's it. Okay, what do we get? No match recall. Bold. So that's the first one that will trigger it. So we should actually stick it there. Oh, actually, yeah, we'll stick it there. So one time, let's just sort these out. Shuttle saturated. So that was called once, and this was saturated once. Because it should obviously do it before and it should do it after. And then of course it should do it before and after again. So we're going to again require before. Let's just line this up. And there we should have what we need. And we do. So now we just want to make sure that we're not being silly. If we move this up, this should fail test. And it does. Right. And this is fine. Always reset on the third go. So we're done. See, the problem with mocks is I could optimize this. I shouldn't even need to call out equals. I'll just take the new pin state can literally be the object. But I need to clean up the test to do it. So because if you are resetting, right, then it's going to have them all up, and it's just going to end with new state. So you might as well just use the new state instead. But it works. At least it works. So just quickly compile again, make sure that's true. Yeah, and we are working. Excellent. So at this point, we've got a fully fledged implementation, and obviously we're going to refactor it. So once again, we're going to have a new header file, and it's going to be called final frame. And get rid of this, and let's just cut and paste. So obviously gut the class out for starters. In fact, we want those headers, don't we? So we're going to take all of this lot, say guy, stick it in here. Hopefully that should. It's missing a few things, so let's fix that. Do I have that in my? Oh, just by sheer luck it worked. Okay. Got memory, we've got variant, appears to be everything it needs. So next is to make sure it still compiles. So it should, and it does, and it still works. So now we can have an implementation. So we've got our final frame class. Yep. And I'm just going to snag all of this stuff, copy it, and paste it after including. That. Oh Christ. Can I make it indent? Code. Folding completion. That's not my idea of formatting, buddy. Let's just start that again, so let's get rid of you. New source file. Add to the test as well. No. Well. You know what, let's not paste it then. And let's just clean this up first. So our enum class, that's local. This is going away. Now it's going away. And then we got this. We got this. And we got this. And we got this. Why do you do this to me? Why? Right, let's get the syntax highlighting right, and maybe it will fix itself. That's more like it. Okay, code. There we go. Whew. It's a bit annoying. Okay. So everything's in the translation unit. Does it build? It does, and it runs. Okay, so that's our final frame basically implemented. So you're looking good. Alright, got a little bit longer, so if anyone wants to see the last part, I think we can implement our frame set. So we're going to have test frame set. you'll see this come together like a jigsaw puzzle, in fact, because since we interfaced away the frame, we can have a mock for that. And we can actually test the scoring independently, and then we can bring it all together and see how badly we messed up the integration. And if we did, then it is the point that you do need integration tests still. Simply having a bunch of separate class unit tests aren't always enough, but generally speaking, you could be surprised. It may well work quite nicely. So we're going to first of all create a header for our mock, so we'll call it mock frame. And no, we don't want that. We're going to create a mock for it. So I need to snag the implement. I'll just snag it from the frame. So mock frame, paste it in. Do it on the class though. There we go. I don't need that. Now I need to actually use this stuff. So mock comps. Let's just nick those. Fix them up. Right. So first is bold, and it's actually it's a void. Okay, and then we've got our bold should be, no, it's not const, is it? What's it whining about? Oh, forgot about that. Probably want to include tropology. And then, of course, we've got turn ended done. So we'll just finally and that's done it. Right, we've got a mock class, ladies and gents. So that does everything we need there. So let's go over to our test, which we called something. Test frame set, that was it. So we catch. Need our mock frame, which I'm sure trying to for us. We do need that lovely extern statement. Where I ain't gonna link. And then that should do the trick. So, look at that right now. So, test frame set, we need a scenario. So, scenario, probably the simplest one is a complete frame set. Should you complete a frame set? Yeah, a frame set where we bold nothing those empty frames to score or given but the interface for the frames, it's a problem. Do I want to mock it? The problem here is composing it with an interface, maybe not the best idea. And maybe I won't mock it after all. Maybe it should be concrete, but then the problem is we're testing. not really separate. Then it's then testing frame as well, which is not necessarily bad because the two are codependent. Frame set is essentially utterly useless. If the but then we could give it to it. We could say we could template it. Yeah, this is a bit tricky. This is a design issue now. We can either couple them directly, or we can try and interface them away, but it creates challenges for mocking and testing. All right, since I think they're inherently codependent, I'm going to go with the option of not mocking it. So I'll leave that around. I'll probably delete it later. So a default constructed frame set. When bold total misses continuously. So let's see, you'll get what, 20 goes across 10 frames? 2, 4, 6, 8, 10, 12, 16, 18, yep, 20. Now the question is, what do we give it? Because it needs to pass through a mock pin set, or it can know the pin set as well. Probably shouldn't though, because the pin set is designed to be some kind of like a sensor or something we can generate. Yeah, so we'll say bold, and we'll have a mock pin set instead. James give it to it in here, so it needs to be a curly braces. I'm not testing this, I'm just going to allow call. Right, so that will bowl 20 times. And that's pretty much all of the game done. So then we'll say then our total score should be 0. That's correct. Require is it called a set or a game? I'm going to call it a frame set. It's technically a game. Well, technically not, because a game could consist of multiple frame sets per player. So we're going to have a frame set. So not set. So now I just need to declare it. And make it compile. So and then we need to ended. And then we need a score. So it's maximum 300, so it needs to be 16 bits. Let's return 4 so no it fails. And just make sure it compiles. And to the end score. I think there's a different word I can use here. Is it expect? Check, isn't it? Check. Let's start using check. Don't want to just require for everything. It should fail. Otherwise it's not helpful. It just stops there. And they both failed the check, so let's make them pass the check. And nothing. And we've done literally nothing useful, but it does pass. Okay, excellent. So we need another scenario. So scenario, we'll have another relatively simple one. Frame set where we score. And let's say I could change that allow call to require call. And then you would be forced to use it. It's probably well, I'll stick with allow call for now. We'll be forced to generalize anyway. So frame set will be score. Say 7 once. Score 7. So I'll just grab all this. Bold. Tell them this is 4. And say 15. Right? 15 to 46. It shouldn't matter. 15 goes. And when bold single 5, get that in there. So we can just grab this. I don't really like this much copy pasting in the tests. So that's 16, 17, 18, 4. So it's 15 plus 1 plus 4. I could do a setup for this and make it return 5 on the 15th go, but it's sequential for now. Okay, so when we do that, it should be 5. Oh, I said 7, didn't I? We'll say 5. What am I saying? This is 5. So do it. And of course we failed, right? So can't make it return 5, so now I need to generalize. So this is going to need to include a frame. So we need to compose this for a set of frames, and strictly speaking I need to compose it with 9 regular frames plus 1 special, but since we have no test for that yet, we're not going to bother doing that. So what we are going to do is have a std array of the standard of the current one. I could, well, interfacing is going to be a bit annoying, but we'll deal with that in a bit. So we're just going to take the enough to get it to pass. I'm going to include array. So since it's concrete, I just have to pass it in. So I need a counter as well. So do I need a counter? Not auto. So current frame, and then we can just do frames, current frame. Do that. Wait, what? Never was remove this TDD pointer. I pin set to const I. Oh, yeah, of course. Doesn't need to own it, does it? Silly. Yeah, there we go. Oh, but then we need to make the frame. Ooh. Ooh. It needs to build it itself. Maybe I do want to interface this way out. It's part of the problem. Part of the problem you have here is that it's not gonna do what we want. Unless we couple it to pin set, which is a problem because we don't really want to do that. So I think we are going to have to interface it away, in fact. And that presents a bit of a challenge. Because it knows the frame type, but each frame constructs with a pin set to use. I don't really want to couple it to that. That defeats the object. You can make a constructor, of course, that takes 10 of them. Maybe that makes more sense. I think we might need a constructor here. And then we can use bold that way. Then it needs, yeah, okay. So we're gonna modify this slightly. Given a frame set with 10 frames. Do I want mock frames or mock pin set? It only passes it through, we should never inspect the pin set, so I'm going to go with mock frame set. Okay, so we're going to do that. So mock pin set and mock frame set. Mock frame rather. And this is going to include an iframe. But we can't use iframe because it can't store it because it doesn't know the type. So it's going to be an array of unique pointers. One of the things here is that you are potentially losing some optimization, but I'm taking the modern C++ approach, and naturally, so if you LTO this, I would generally expect that you probably won't even pay for the unique pointers. But this is how you segregate design. Well, you could go into templates actually. I'm trying to keep it idiomatic. So what we're going to do is set it up. So let's have a quick setup function. So we're going to have a array. Right. What's the problem with that? Is that. So just so I can quickly generate the mocks. Still need to find. Actually, I need this to give me back a pair of bloody things. Could use stood pair, but that's going to look horrible. Here we go. Stood pair, stood arrays, and probably have a using statement for this. What's wrong with that? Comma. Right, so I'm not sure I'm a massive fan of that. Why is that not? Can we include the utility, please? Nice. Oh yeah, oops. Does it work on functions? You know, let's just do a using statement. Using, what should we call it? Rather than trying to be too smart. No matching constructor for pair of. Why not? We can just build it as we go. Alright. So let's do the array first then. And I need the reference wrappers as well. I need to bind them again. Oh, that's not fun. Because they have to exist. Oh, Christ. You can't have you can't construct a reference wrapper that's not assigned, which means it needs a bloody initializer list. That's just going to be a whole chunk of code that I can't fit in a loop, which I really don't want. Since it's for the unit test, I'm just going to use a vector instead. Let's shut that up over this. So, unknown type frameworks. Alright, so it's a pair consisting of a vector, reference, and a pair, right. And then we'll just declare the vector here. Might as well reserve 10 because why not? It's a little bit more code, test code than I like, but it's fine. And actually we can bung it in here as we go. So this, and then we can do and that, my friends, is valid syntax. So for anyone wondering what the hell it's doing, this is an automatically produced ref type. Auto add would work actually, since it's a proper L value, but we're going with that. We obviously assign it a new one, and then we directly construct a reference wrapper to obviously reference inside the pointer. And then finally, because it knows the return type is a pair, this just constructs a std pair while the curly brace on the outside. Std moves in pointers and std moves in refs. So we've got our little generator there. Not the prettiest thing in the world, but it'll do the job. So frames at 10 mock frames. So to generate them, so and now it needs a constructor. And what's wrong with that? I didn't give it details. You know what? I'm just going to declare type it. We know what the type is. Right. So that doesn't work anymore. That does that. So I need to change this slightly now. So I need to allow call on these. And the function is what, bold? Yeah.
frame, and that opens up to a, oh wait, no, that could be an iframe, that's fine. So this is the problem. It's not going to work there now because they've made one. That's technically upcasting. I'm not entirely sure if that's legal, but we can easily get around it if it isn't. So we then say so we don't actually care about that. Okay, this is actually not so bad. This is abstracted away at least. So we allow the call on all of these. So we use them all. I suppose you should require actually. I should call each one twice. And then we're going to bold. And I need to set this up again. So let's it's going to be, this is wrong, this is all wrong, I don't want this. Do you need the loop though? It's not very clever points. Right. Just take a pause and look through this. So it takes ownership of the mock frames. It's going to call bold on the mock frames with those pins. It doesn't. It's it is segregated nicely. So that's right. What do you mean it's never used? What do you think that means? You dark piece of trash. So it's going to call bold, and our first test is going to make sure that it does it twice for each one. We miss, and we get a score 20. Let's just see if it builds, because I'm sure I've got to fix some stuff now. Yeah, function does not take 0 arguments is usually a good reason for being broken. Yeah, so over 15 of these, we don't want to construct this anymore. Give it a fake, a dummy. And then what we do here, we don't need any of this. Just give it some crap. And again, just give it some trash. Maybe I should use a fake there, but anyway, let's try that. Blow up horribly. Starting bar error. And another 2 overload to convert all the argument types in where? No, I did star. No. Yeah, I knew it. This is what I was saying. This is not going to work because it's a downcast. An upcast. It's downcasting or upcasting? It's upcasting. So the problem is that the type of this is an array of unique pointers to iframes. So by this point, it's lost the type completely. So the type safe way is to add a new line and capture the ref, but I'm going to be slightly lazy because we know exactly what it is. We can see it on the previous line. It's a mock frame, so you're going to get a mock frame ref. Okay, so now what's blowing? Oh, look at all this. That's quite a lot of stuff. Damn, that's spammy. Okay, so the first thing is we're bonifying. Okay, so this is broken as check failure empty, false, unfilled expectation, bold, and it's never called. So how do we violate that? We call it 20 times, and of course it is actually broken because we don't increment the bloody variable. So actually it's got to, we need it to be sequenced somewhat. So we're going to need to, I'm slightly afraid of the object going out of scope here. Look, can it be completely sequential? No, it can't. I'm not sure if this is going to work. I'm not entirely sure if this is going to work. Oh dear. Maybe it makes a share pointer internally. If it doesn't, I am without a paddle. So it's going to call bold, and then it's going to call turn ended twice. So require call and then return true afterwards. My only fear is that if I'm supposed to keep the sequence object alive, I'm going to have a really bad testing experience right now. So let's just see if the testing frame, the mocking framework pukes on that. Looks like we might be okay. We might be in luck. I think we're actually okay. Yeah, okay, so in that case, let's do our stuff. So when we start, we're guaranteed to have a bold, so we don't need to check here. So if do that. Okay, actually, let's just focus on one at a time. So this side is broken. I don't need to worry about this one for now. Let's just fix the first one, and then worry about that after. Okay, so here we go. What have we munged up? The check message. Actually, never called. Actually, never called. That's not good, is it? So we have the current frame, which is initialized to 0, we call bold. And what we do, for every mock frame, which there should be 10, give it the first one, we iterate the second one, and it's going to consist of, we're going to call bold twice on each frame, that's correct. Does generate 10 of them, right? Yeah, there's 10 of them. And why are none of them getting called? So on bold, this is, surely it's completed though, right? It can't be when it's, oh, is this something silly like the bloody scope? No, it can't be, they're still alive. The sequence might not be, which would be a problem. Yeah. My fear is that it's
because it's in the scope of this, it's not going to work, which is slightly problematic. So it should be called twice. It's never called. Check failure into expansion files. Where's that? No, that's something else. 59. Never calls anything, does it? Indeed. So should be false and true. I haven't got a lifetime issue. I'm doing something wrong with the testing framework, which is not great. I suspect it's a sequence. You know, let's just do this. So get rid of the sequence. We'll just pop that there. It's probably going to violate the return values and go crazy, but at least it'll say it's called. No, perhaps not. Never called. Actually, never called. Right, we're not accidentally copying here, are we? So we have an array of these. We have a vector of these. So it's 10 of them. We iterate over the empty ones. We fill them in with the real ones. This gets a ref to the object after recasting it. These are reference wrappers, so we can't take the copy. Turn by move constructor on the object. I don't think it will work without that. And then you just fail horribly. So we do call frame set or bold, so we don't call that, that's not going to work. So ice, so 0 to 20, call bold, which goes to here, which does call bold, indexing it by 0 to 10. We do check if turns ended, so why does it say it's never called? How many of these are there? There's 20. How many does it say are not there? It should be something like 20 times 3. One failed. One failed, so that'll be the assertions we've got here for each one. 10 frames times 3 of these is 60. Where's the 60? Where's the 1 came from? 60 makes sense, but not 1. Okay, well, interesting mock issue. I think we're going to round it off here. And hopefully when I get back to you, we'll figure out why that doesn't, well, have info on why that didn't work. But cheers for now. We're nearly there.